Assalamualaikum warahmatullahi wabarakatuh. Feels great to have you in learning on the chapter 3, which is vectors. Now, the first method how we express the position of the vectors is actually using by the Cartesian coordinate system. It is actually represented by the x-axis and y-axis, which is intersect that point, which is called origin. Such as examples, we can express the green point directions as shown in the figure, which is 3 units in y directions, while the green point shows 3 units in negative quadrant. The second point is polar coordinate system in terms of x and y direction, which is now we are looking at the r. The term r is defined as the distance from origin to point that having the coordinate x and y in Cartesian coordinates. Also contain theta, which is the angle with respect to our reference axis, which is x-axis. Moreover, how can we find the r is actually using the concept trigonometry. We can relate the theta using in terms of sin theta equal to y over the r, cos theta equal to x over the r, and tan theta equal to y over the x. We also can rearrange in terms of x equal to r cos theta or y equal to r sin theta. We also can find the angle by using tan theta equal to y over x, and the hypotenuse by using magnitude of the r equal to square root of x squared plus y squared, represented by the x and y coordinates.
I am Nurul Aisyah Nanshwa binti Mak Jusuf. Now, I will explain the second subtopic in this chapter, which is vector and scalar quantities. Scalar quantities are completely specified by a single value with an appropriate unit and has no direction, which means scalars only have magnitude but no direction. The magnitude can be measured with a number. For example, if a car travels at 22 meters per second, 22 will be the magnitude of its speed. Because speed of itself does not have the direction, so it is a scalar quantity. Other examples of scalar quantities include distance, time, and mass. On the other hand, vector quantities are completely specified by a number with an appropriate unit, which the magnitude of the vector plus a direction. This means a vector is a representation of both magnitude and direction. For example, displacement, velocity, acceleration, weight, and force.
Assalamualaikum warahmatullahi wabarakatuh. I'm Hana Sarfina binti Azmi. I would like to continue with the third subtopic for vector, which is 3.3, the basic vector arithmetic. This subtopic is just to give an idea of what we mean geometrically when we talk about the different type of vector. So here is what you have to know. The length of the vector represents its magnitude. Vectors are drawn as an arrow with tail and head. So let's start with the first type of vector, which is addition. When we add two vectors, what we mean by that is we take the displacement of u, adding it with the displacement of v, and total resulting displacement after these two displacements occur is the sum of vector u plus v, which is also known as r in this example. And the second type of vector is subtraction. Like I said earlier, vectors are drawn from tail to head. Therefore, positive and negative sign plays a big role in the direction of the vector. So as you can see here, to get the resultant vector r, we have to add vector u by v. Therefore, vector v must be in negative sign since it goes from the opposite direction. We can think of subtraction as addition because if we have u minus v, we're really just adding the vectors u and negative v. So for the third example, we have the scalar multiplication. So there we have vector u and if there's a vector that was in the same direction as you, but the distance was only 1/2 of what you did, we will call this 1/2 u. This is multiplying the vector by the real scalar of 1/2, and what we get is vector that goes in the same direction as u, but magnitude is only half of what the magnitude u was. Same goes with if we multiply the vector by the scalar of 2. We will get double of the magnitude u, but in the same direction. So here is an example question for this subtopic, which is the sum of two vectors. The question says, find the sum of two vectors, A and B, lying in the xy plane and given by, so this is the vector A and this is the vector B. Notice that the vector B with y component j is negative, therefore it is pointing downward. AX is 2 and AY is 2. AZ is excluded because it's only two-dimensional. BX is 2, BY is -4, BZ is 0. So this is the solution. You just have to add all the x component together and y component together. Therefore, 2 plus 2 for x component and 2 minus 4 for y component. So the answer you will get for the unit vector r is positive 4 x component and -2 y component.
My name is Siti Farisha binti Abdul Rahim. Now I will continue with subtopic 3.4, which is components of vector. Vector consists of two components, which is x component and also y component. And vector has four quadrants, so the symbol of positive and negative of vectors depends on the quadrant of vector. Okay, now unit vector is dimensionless vector having magnitude of exactly 1. Firstly, vectors in 3 dimensions. So for 3-dimensional, there are 3, which is I, J, and also K. And second, for vectors addition using component, it is a little bit different from additional vector because we must add the vector separately according to their component. For I, x component of both vector A and B must be added, and for J, y component of both vector of A and B must be added. And same goes for K, both z component of vector A and B will be added. Lastly, for the magnitude of vector, we must use this formula to find the resultant of vector, which is r equal to square root of rx component square and with ry component square. Okay, now I will continue with the example, which is the resultant displacement. A particle undergoes 3 consecutive displacements, delta r1, delta r2, and also delta r3. Find unit vector notation for the resultant displacement and magnitude. So for the solution of example, we must solve this question using 3 unit vector that we have been discussed just now. This vector has 3-dimensional, so firstly, we must add all the vectors using component for I using x component, and for j, y component, and for k, z component. So we must add all of the vectors separately according to their component. Then after that, you must find the resultant displacement using the formula of magnitude of vector that I have been discussed before. And then you will get the answer, which is 40 cm. That's all from me. Thank you.
So, at the end of this video, I will conclude this chapter with Islamic point of view. Prophet Muhammad came to the first revelation. Located on the Nur Mountain Rock Cave is a place of pilgrimage. The Quran began to descend here, and in many respects, Jibril appeared here for the first time in its true form and has unique significant history of Islam and world religions. It is a miracle that the word Ham-Nur Mount and the word Hira Cave are used side by side in the verse that carry its coordinate number, and it's mentioned that they take revelation. Thus, in these two verses of Quran, which are verse 2145 and 2139, give the coordinate of the Hira Cave. The coordinates of Hira Cave is 2145 degree latitude and 3985 degree longitude. The 5 An-Nara letters, which are the letters of the word An-Nur, and 3 words of the word Hira, are united in verse. Of course, they are mentioned in different words, but it is very difficult to happen by chance. So with that, that's all from us. Thank you.